So hello everyone, I'm Mark Jackson. I'm the Quantum Evangelist at Quantinuum, which is the recent merger between Cambridge Quantum and Honeywell Quantum Solutions. We are now the largest quantum computing company in the world. We have over 400 employees worldwide. So we obviously have a strong presence in the US and the UK. We also have offices in Japan and Germany, and soon to be opening up one in France. We have applications in every area that's been talked about today. So this includes chemistry and machine learning and optimization and even natural language processing uniquely. But what I'm going to talk to you today about is TKET, and this is the glue that keeps everything together. So TKET is the liaison between quantum algorithms and interfacing with the hardware or simulator. Now, we realize that right now there are many choices in quantum programming languages. This includes IBM's QuizKit or Google's Cirq or Microsoft's Q#, among others. And there are many platforms, and I've listed a few logos here. So these are some of the major ones, and there are many, many others, and this increases every week. The problem is that using one of these languages tends to limit you to the platform that you use. And in addition, it doesn't always run as efficiently as you'd like. And especially in this NISQ era, this could mean the difference between your program working and not working. And this is why we developed TKET. So TKET is a quantum software development kit, which is completely agnostic with respect to both the language and the platform. So you can use any of the languages on the left-hand side and execute your program on any of the platforms on the right-hand side. And furthermore, TKET will automatically find the most efficient way to execute your program. And you don't need to know the details. TKET will do all this for you. You simply add one line to your code saying, use TKET to compile my software, and TKET will do the rest. So you can keep your existing software in QuizKit or whatever, and you just indicate which platform you want to run it on. Now, there's two ways that it does this. The first way is by optimizing the circuit itself. And this is independent of the hardware. And I'll give an example in a second. And the second way that it does this is it does use the details of the hardware and it solves these constraints. And again, I'll give an example in a second. So these are some of the optimization procedures that TKET does on your circuit. And you see that there are several examples here. The upper left-hand corner is an obvious example of two C0 operations in a row canceling each other out. And so this makes your program run a little bit faster and be a little bit less likely to make a mistake. And these others are all, again, mathematically identical. It just takes a little more time to work this out. If you're curious about the mathematical details, I've given an article referenced here. So the second part of this, as I mentioned, was solving the constraints specific to the hardware. And there's a few different components to this. So one component is TKET is aware of the platform, of how the qubits are connected, all the couplings between them. And so TKET will automatically route the information around between the logical qubits and the physical qubits to maximally optimize this. It also makes the translation between the gates that you may have used in your circuit and those which are native to that platform. And then finally, any sort of delaying measurements that it can do if your platform supports that. Of course, we use TKET for our own internal quantum algorithm development, but many other groups have been using this. This includes IBM and Google and even CERN. And this includes here on the screen some of the articles that have been written. And almost in every case, you will see an increased efficiency in running your software using TKET. We are constantly updating it. We always have new versions. And last September, we made a major change to it. We made it open source. So it's not only free to use, you actually can inspect every line of code yourself. So if you have some clever idea, you're welcome to contribute to this. If you have your own hardware platform, of course, you can write your own extension so that people can write software and run it on your platform. This is the GitHub repo. If you'd like to take a screenshot, I welcome you to do so. This is how you download it from GitHub, and then you just install it using the usual pip install. And so if you have any questions, please feel free to get in touch with me. This is my email address and the TKET support email address as well. Thank you.